Hiya, hope you're doing alright. The other day, I came across a really nice Oxford Maths Aptitude Test question, and I thought about adapting the problem so that I could share it with you. So here we go. Find the real solutions to this. So recalling the laws of indices, 27 is 3 cubed. So 27 to the x is 3 cubed to the power of x, or vice versa. So I'm going to write 3 to the x, all cubed. We can follow the same logic, so we can write that's 3 to the x, all squared. And here, 3 to the x plus 2, well, I would think about it as 3 to the x times by 3 squared. 3 squared is 9, so we can write this as 9 times 3 to the x minus 9. Now, this looks all right, but I would like to move all the terms to one side so I can make the other side equal to 0. So I'm going to move everything to the left-hand side to get 3 to the x all cubed minus 3 to the x squared minus 9 lots of 3 to the x plus 9 equals 0. So hopefully we can see that this is a disguised cubic. Now, we could just solve for 3 to the x, but it looks a bit challenging, so let's just use a substitution and let 3 to the x equal y to make our lives easier and reduce the errors we make. So I'm just going to rewrite this as y cubed minus 3, y squared minus 9y plus 9 equals 0. So this is what we have at the moment, and let's try and factorise it. So y equals 0. Obviously that won't work. 9 does not equal 0. What about y equals 1? So 1 minus 9 plus 9. Yeah, that works. So y equals 1 is a root, therefore y minus 1 is a factor. Now, the resulting quadratic. You can go about this many ways, maybe long division, but I just like to do it mentally. So I'm going to think, how can I get a y cubed? Well, times it by y squared. So we have, I'll just write to the side, y cubed minus y squared. So these two terms are covered, they're all good. Now, to get a minus 9y, I'm going to write minus 9. So we have, expand that, minus 9y plus 9. And oh look, that's literally what we have here. So that's all good. That's the quadratic. I'm going to equate each bracket to 0. So we have y minus 1 equals 0 and y squared minus 9 equals 0. Now hopefully we can see that y squared minus 9 is a difference of two squares. So I'm just going to write to the side y minus 3 equals 0 and y plus 3 equals 0. And let's rearrange this to get y, the subject. So we have y equals 1, y equals 3, y equals minus 3. And let's get it back to 3 to the x. 3 to the x equals y, so I can just put here 3 to the x equals 1, 3 to the x equals 3, and 3 to the x equals minus 3. Now, most students would just stop here and say that there are 3 real solutions to this problem. Now, this is where they go wrong, because they assume these solutions work. Let's actually go through it. So, if we look at 3 to the x equals minus 3 and question it, let's think about it. Let's draw the graph of y equals 3 to the x. So we know it passes through 0, 1, and it'll look something like this. A really bad sketch, but it will do. Now, can you see that there are no negative y values? In other words, every single output of x is positive. It's always above the x-axis. So 3 to the x can never equal minus 3. So we're going to put a not equal sign here. We reject this value. And then let's look at our other two solutions. Do they work? And if so, let's find what x equals. So 3 to the x equals 1. Okay, hopefully you can see that x equals 0 straight away. Or, if you've watched my previous logarithms video, you can say that log 3 base 1 equals x. And you know that log base anything of 1 always equals 0. So, yes, x equals 0. And here, 3 to the x equals 3. Pretty simple. X equals 1. So there we go. Two solutions, x equals 1, x equals 0 to this problem. Seems pretty hard at first, but it's not that hard. Personally, I thought it was a really nice problem, and I hope you enjoyed it too. Thank you for watching, and I'll see you in my next video. Bye-bye.